Welcome to Keentel Engineering. In this presentation, we're breaking down the 10 IEEE standards released or updated in 2025 and what they mean for substation design, grid reliability, cybersecurity, and distributed energy integration. Standards don't just define compliance, they define what a modern, future-ready substation actually looks like. Let's get into it. In 2025, the IEEE released or updated 10 standards that every substation engineer needs to know. IEEE 57.19.100, Power Apparatus Bushings, C37.251, the ComSet Protection Configuration Format, 1686 IED Cybersecurity, 495, Faulted Circuit Indicators, C37.1.2, Automation Databases, C57.170, Transformer Condition Assessment, C57.13.10, Energized CT Calibration, C37.13.1, Low Voltage Metal Enclosed Switchgear, 1815.2, DER Communications using DNP3, and C57.94, Dry Type Transformer Maintenance. 10 standards, spanning hardware, digital configuration, cybersecurity, asset health, distribution automation, and renewable integration. One unified philosophy: build substations that are electrically sound, digitally integrated, cybersecure, and ready for the grid of tomorrow. Starting with the foundation, physical hardware and digital configuration. IEEE C57.19.100 covers power apparatus bushings. Improper bushing selection leads to partial discharge, thermal runaway, and catastrophic transformer failure. The 2025 edition tightens guidance on BIL coordination, pollution class and creepage distances, seismic loading, short-circuit mechanical forces, and transient overvoltage exposure. Selecting a bushing based on nameplate voltage alone is not engineering. IEEE C37.251, ComSet solves the digital configuration problem. Before this standard, every relay vendor used proprietary settings formats, making multi-vendor integration slow and error-prone. ComSet defines a standardized IEC 61850 SCL-based format for protection configuration data. The result: interoperability across vendors, structured version control, automated commissioning validation, and fewer integration errors at energization. Cybersecurity is no longer an IT afterthought. It is a core engineering design requirement. IEEE 1686, updated with a 2025 core addendum, defines mandatory cybersecurity capabilities for every IED deployed in a substation. Role-based access control, cryptographically validated firmware updates, tamper-evident logging and auditing, encrypted communications, integrity checks on all external interfaces, and secure remote access using VPN and zero-trust architecture. Modern substations are networked, which means every IED is a potential attack surface. IEEE 1686 defines the minimum acceptable defense posture, aligning with NERC CIP, IEC 62351, and Zero Trust design principles. 3 standards covering the full stack from distribution reliability to renewable integration. IEEE 495-10's 2025 updates faulted circuit indicators. Smart FC is integrated with SCADA, cut outage restoration time significantly, with the 2025 edition adding SCADA communication requirements and FLISR support, fault location, isolation, and service restoration. Better SAIDI and SAIFI metrics are the direct result. IEEE 37.1.2-2025 addresses database architecture in utility automation. Digital substations generate massive volumes of event and operational data. This guide defines how to structure, retrieve, and maintain it, covering historian architecture, IEC 61850 logical node mapping, and cyber-hardened database interfaces that feed faster disturbance analysis and predictive maintenance. IEEE 1815.2-2025 standardizes DER communication using DNP3 mapped to IEC 61850-7-420 data models. Solar, wind, and BESS facilities now have a defined, secure, interoperable protocol for utility SCADA integration, which is what makes a modern collector substation actually function. 3 standards focused on asset reliability. IEEE C 57.170-2025 formalizes condition assessment for liquid immersed power transformers, covering dissolved gas analysis, thermal aging evaluation, bushing condition assessment, insulation life modeling, and risk scoring. The shift is from time-based maintenance schedules to data-driven asset management. That reduces both risk and unnecessary cost. IEEE C57.94-2025 covers dry-type transformers, increasingly critical in indoor substations, data centers, and urban renewable plants. The guide addresses ventilation load analysis, harmonic mitigation, temperature rise coordination, and fire risk mitigation. IEEE C57.13.10-2025 brings structure to energized CT calibration at 34.5 kilovolts and below. CT accuracy is foundational to everything downstream: protection sensitivity, fault detection, and revenue metering. The standard defines energized calibration methods, secondary injection interfaces, and arc flash safe test procedures. Inside every substation is a low-voltage world most engineers overlook until it fails. Station service panels, protection relay panels, battery chargers, HVAC, SCADA servers, all running on low-voltage metal-enclosed switchgear. If that infrastructure goes down, the substation goes blind. IEEE C 37.13.1-2025 governs the construction, performance, and testing of these systems. At Keentel Engineering, every LV design includes full NEC compliance, short-circuit withstand ratings verified against fault study results, arc flash labeling per IEEE 1584, selective coordination studies, and N1 redundancy for critical station service loads. The low-voltage system is the nervous system of the substation, and it gets treated that way. Every one of these 10 IEEE 2025 standards touches a different dimension of substation engineering. Keentel covers all of them. HV and EHV substation design from 115 kilovolts to 500 kilovolts. Protection and control, including relay coordination studies. IEC 61850 engineering with Goose and MMS. SCADA and automation design. Collector substations for solar, wind, and BESS. Transformer condition assessment with DGA and asset life modeling. Cybersecurity engineering aligned with NERC CIP and zero trust principles. And grounding and lightning protection per IEEE 80. 30-plus years of power system expertise. One design partner for every standard on this list. Why do the 2025 IEEE standards matter? Because the grid has fundamentally changed. Renewables, digitization, cyber threats, and aging infrastructure all demand updated guidance, and these 10 standards deliver it. What is ComSet? The IEEE C 37.251 standard, a structured IEC 61850 SCL, based format for protection configuration data that enables multi-vendor interoperability and eliminates manual settings integration errors. Why does IEEE 1686 matter now? Because every networked IED is a potential attack surface. The standard mandates secure access, encrypted communications, tamper-evident logging, and data integrity verification for every protective device. How does C57.170 improve transformer reliability? By replacing fixed interval maintenance with structured data-driven condition assessment, DGA trending, thermal modeling, risk scoring, and remaining life estimation. And how does 1815.2 support DER integration? By giving solar, wind, and BESS systems a standardized, secure DNP3 communication profile for utility SCADA, consistent and interoperable across every project. The grid is evolving. Cyber threats are real. Renewables are accelerating. Protection is digital. And compliance requirements tighten every year. Your next substation needs to be electrically sound, digitally integrated, cyber secure, IEEE compliant, and future ready. Keentel Engineering delivers exactly that. Whether you're developing a 345 kilovolt transmission substation, a collector substation, a BESS interconnection yard, or a GIS installation in urban territory. The link to start that conversation is in the description. Let's build your next substation with confidence.